Some of you wanted to see how to build the multiple regression table using Excel. So I will start at our D2L page. I'm going to grab some data to perform regression analysis on. Then I will manipulate the results to get the table that we are after. So here we have a data set that's been set up to examine median household income as a function of population, age, percent population with diploma, and percent 16 or older with job. The first step is we need to run a regression analysis. I have this set up with my Y variable in the leftmost column, which is always a good idea. Hitting Control Shift right and down will select all of your X variables. Indicate labels if you use them. It's recommended to use them. That way you know what the results mean. New worksheet, okay. So what we get here is a pretty normal looking standard Excel regression result output. I'm now going to clean it up a little bit. Reduce the number of decimals to a reasonable amount by double-clicking on the paintbrush, so we can keep that format and use it elsewhere. Escape will get you out of that format paintbrush. Of course, we get rid of the extra confidence interval results, which we won't need. So this is our basic regression output from Excel. And for the purpose of the project in my course, you will need to report all of these results so that I can replicate your findings elsewhere in the project. However, typically when reporting regression results, we don't report all of this information. A lot of it turns out to be redundant. So what we will do is we will set up in the space to the right a cleaner, more presentable regression result table that focuses on the coefficients and their statistical significance. This format lends itself to multiple regression and comparing the results from regression that come from different models, including different variables. So we'll do a little bit of that in this video. We're going to focus on the results of the coefficients and the standard errors. So I will pull those out. Now we're going to need some room to work. So I will separate these out. And you won't need the intercept, generally speaking. That is not reported or interpreted. There we go. I'm also going to clean this up a little bit so we have shorter labels. You can be as specific as you want, though, since the format of the table is long. All right. Typically, I'm going to clean up the border down here. Typically, these results are reported stacked with the coefficients on top and the standard errors below. After reading a bunch of these tables, you get used to comparing the magnitude of the coefficient to that of the standard error to get a sense of statistical significance. So also a convention is to include the standard error in parentheses, so we're going to go ahead and add those as a format. So we're going to format cells with a right-click, format cell, number, custom, and we're going to put in the following format: parenthesis, hashtag, 0, that way you get a 0 before the decimal point, 0.000, parenthesis. Okay, now these are very presentable. We're going to take these, Control-C, right-click, paste special, and transpose. Oh, beg your pardon. Try that again. Control-C, right-click, paste special, skip blanks. There it is. And you can delete the originals. And oddly, the format did not carry with it. So I'll just paste these. I'm not sure why the format did not carry over. Now, as far as the labels, I like to merge them so that they will fall eventually right between the coefficient and the standard error. In order to make that happen, I right-click, Format Cells, Alignment, and then center it. Say OK. Then you can use the paintbrush to carry that format down. Oddly, it looks as though I've wiped the number of decimals that we were using there. To center this, you can often get things to line up quite well. However, sometimes that's not going to happen. The last thing we want to do is indicate statistical significance. So we'll carry this format once again over here. And what I will do is I'll use a little nested if function equals if. We'll go to the p-value for the particular variable we're working on. And if that is less than 0.001, comma, star, star, star. If that's not true, new if function, if it is less than 0.05, comma, star, star. And if that is not true, then if, parenthesis, this is less than 0.1, comma, quote, star, star, oops, 1 star, and comma, nothing. Parenthesis, 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 enter. Forgot to indicate the cell that I'm looking at. Enter. There we go. And this seems to not be looking in the right place. So we'll make sure they're looking in the right place. And now everything is pretty clear. So we'll deem these results model 1. And we need to indicate in the bottom here a couple of things. The first being adjusted R squared. We can simply take this, copy it, paste it right here. Or maybe not. And 4 decimals here is fine. And then finally, observations. Clean up the borders. Add a border up here. That looks pretty good. So now all that's left is to use another model. We'll go back to the data. But before we do, notice we have one variable with a p-value of 0.984. That's probably not statistically significant. And while it's not a very well-received method, we can utilize stepwise regression to eliminate a variable that clearly isn't pulling its weight. Theoretically, you can make an argument as to whether or not median age should factor into our model for median household income. Perhaps it does, and perhaps it's not linear. Regardless, to show you the model development and the usefulness of this presentation, we will go ahead and run the model again without that variable. You would want to leave your original data the same. I'm simply pulling this off to the side in the data that I'm working with. Once again, data analysis, regression, okay. And this time when you select your X variables, you will not select median age, okay. All right, so here we have a second set of results. I'm going to pull the results that I'm interested in over to the original tab that I was working on. Just making sure that everything lines up properly. We left median age out, so we'll leave those two empty. And now everything lines up. Actually, let's just go ahead and grab the entire set of useful information and import it over here. There we have it. So population and population, percent population with no high school diploma, and percent 16 or older with a job. So this becomes our second set of coefficient estimates, and this becomes our second set of standard errors. Grabbing the paintbrush. We're going to hit Control-C, right-click, Paste Special, and skip blanks. Skip blanks. Something did not quite work there. Oh, I see. Control-C, right-click, Paste Special, skip blanks. Okay, there we are. That looks pretty good. I'll grab the format paintbrush once again and paint the coefficients. Hit escape. Now we need to grab, well, first of all, let's change this function. And bring it down to where that should be looking at there. Let's see if we can drag it down properly this time. Nope, that is not going to work. Alright, so this will be for the second variable. And the last variable. Alright, so what we see is in our Model 2, merge and center, I will go ahead and separate these out, clear out the borders, just give us a little breathing room here between the two models. And now we need to grab our adjusted R squared, which went up ever so slightly. And our sample size, of course, is not changed. And then I will go ahead and merge and center these two outcomes as well. But what we can see is, strictly speaking, we do have a slight improvement when moving from model 1 to model 2, and that is accomplished without the variation generated by median age, so that it doesn't appear to be a useful variable, at least as modeled in a straightforward linear way. What we end up with here is a nice presentation of the key results from regression analysis, ignoring, of course, the ANOVA or F-test results and some of the aggregate regression results such as standard error, multiple R, etc. So I hope that this helps. You can continue to run models and examine changes in adjusted R squared. However, in this case, everything is significant in the second model. So to finish things up, I would take these results and I would eliminate the grid lines, highlight the results as such, open a Word document, and then paste special as an enhanced meta file. And you can always do little things to clean it up. Try your best to line up the decimals, for example, apart, of course, for the results for adjusted R squared. Sometimes you might want to make this a wide column to differentiate the results for R squared from those of your coefficients. But there you have it.